Today, we will be talking about series and sigma notation. Series and sigma notation, given a sequence A sub 1, A sub 2, A sub 3, and so on, A sub n. Its corresponding series is the infinite series. Okay, now what is sigma notation? A sub 1 plus A sub 2 plus A sub n equals, we have the symbol for sigma notation, and the k equals 1, and then n and A sub k. This is the formula for the sigma notation. The given expression is called a summation. The symbol, like E, is the Greek letter sigma. The letter K is usually called the index of summation, which can be replaced by any other letter. So we can use A, B, C, etc. And the index of summation is kung asa mag-start ang ato ang value nga i-replace sa variable k. And here, the starting value of the index summation need not be 1. So, pwede 0, 2, 3, and so on. For instance, the above summation can also be written as the k is equal to 0 and then n minus 1 and A sub k plus 1, or we can start with k is equal to 2 and n plus 1 and then A sub k minus 1. In fact, in general, we have the sigma notation symbol, then k is equal to 0, and then n A sub k is equal to the sigma notation, and k is equal to j, and n plus j, and then A sub k minus j. Example 1. The following are examples of finite series. Finite means may katapusan, or there's end. Example, our k is equal to 1, and then our n is 4, and we have k squared. Since we will start with 1, it should be in order. So our k is 1, and we need to square the k. So our series will be 1 squared plus 2 squared plus 3 squared plus 4 squared. So our end, or the last number, is 4. So our last series is 4 squared. Second example is our k is 1 and our n is 6. And we have 1 over k, or 1 divided by k. Since we will start with 1, so we have 1 over 1 is equal to 1. And then plus 1/2, plus 1/3, plus 1/4, plus 1/5, plus 1/6. So our index is 1, and the last number, which is n, is 6. So we'll start with 1 over 1 or 1 up to 1 over 6. Next is our n is 0, and our last number will be 2. So we have square root of n minus square root of n plus 1. So that's our equation, or that's the expression. So since our starting number is 0, so we have square root of 0 minus square root of 1. Why square root of 1? Because our n starts with 0. So 0 plus 1 is also 1. So we have square root of 0 minus square root of 1 plus next number of 0 is 1. So we have square root of 1 minus square root of 1 plus 1 is 2. So we have square root of 1 minus square root of 2. And the last number is 2. So we have square root of 2 minus n plus 1. So our n is 2. So 2 plus 1 is 3. So we have square root of 2 minus square root of 3. So in having finite series, just look at what is the index and the end of the number. It is not necessarily nga 1 ta mag-start. We can start with 0, we can start with 2, 3, 4, etc. It depends upon the given k, with the given index. And so with the n, which is the top of the sigma notation symbol, that's the end of the number, or kung diin matapos ang number that we're going to substitute sa given expression. Okay, we will proceed to example 2. We write the given series in sigma notation. So it's the opposite. The series is given and we will make a sigma notation. The given is 2 plus 4 plus 6 plus 8 plus 10 plus 12. Note that the terms of the series are just the first 6 consecutive even positive integers. So we look at the given series in sigma notation. So 6 sila ka-consecutive even positive integers, meaning kanang mga numbers nga pares like 2, 4, 6, 8, 10, 12. They're called even positive integers. That is, they are all the form 2 times the n, with n ranging from 1 to 6. Thus, in summation notation, the given series can be written as follows. So our n is equal to 1. And the last number will be 6. And our expression is 2 times n. Because if we will start with 1, we can have 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. So from 1 up to 6 as the value of n. Number 2, we have 1/4 minus 1 over 7 plus 1 over 10 minus 1 over 13 plus 1 over 16. So notice that the difference between successive denominators is always 3. Diba? You look at the denominators. We have 4, 7, 10, 13, 16. So na ay constant nga difference nila. Diba? 16 minus 13 is 3. 13 minus 10 is 3. 10 minus 7 is 3. And 7 minus 4 is 3. So, there is always 3 nga ilahang difference. That is, they form an arithmetic sequence with common difference 3. So, there is a common difference 3. That is, the denominators are of the form 3n plus a constant, or 3n plus c, or 3 times the n plus c, where c is a constant determined by the first denominator. If we choose to let n start with 1, then since the denominator corresponding to n is equal to 1 is 4, so the proper c must satisfy the following. So 3 times 1 plus c equals 4. That is, c is equal to 1. So we have 3 times 1 is 3 plus 1 is 4. So we can have that denominator 4. Next is 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. And 3 times 4 is 12 plus 1 is 13. And 3 times 5 is 15 plus 1 is 16. So we can have that form, and we can get those denominators there. So the terms in absolute value are of the form 1 over 3n plus 1, where n starts at 1. Now we still have to consider the alternative signs of the terms. We thus multiply an extra negative 1 to the power of n, or negative 1 to the power of n minus 1 to the terms to make this happen. Since we want a positive term, when n equals 1, we choose negative 1 to the power of n minus 1. In summary, the given series can be written as follows. The sigma notation, and n should start with 1 and ends with 5. And we have the formula here, negative 1 to the power of n minus 1 all over 3n plus 1. So we choose negative 1 as the base because the symbol in every term of the series is alternate. Positive, negative, positive, negative. Okay, we will proceed to example 3. Evaluate the following sum. Our k is 1, so it starts with 1 and ends with 24. And the expression that we're going to evaluate is 1 over square root of k minus 1 over square root of k plus 1. So let us write out the addends of this series. Since it starts with 1, so we have 1 over square root of 1 minus 1 over square root of 2, because we have k plus 1, 1, and our k starts with 1. So 1 plus 1 will be 2. Then plus 1 square root of 2 minus 1 square root of 3, because 2 plus 1 is 3. Plus 1 square root of 3 minus 1 over square root of 4. Plus so on up to 25. Why? Because the last number is 24. So we have 1 over square root of 24 minus 1 over 24 plus 1 is 25. So we have square root of 25. Observe that the middle terms cancel out because it's minus. So thus, we are left with the first and last addends only. So we can have 1 over square root of 1 minus 1 over square root of 25. So as we know that the square root of 1 is 1. So 1 divided by 1 is also 1. Minus 1/5. Why 1/5? Because the square root of 25 is 5. And if we will subtract it, 1 minus 1/5 equals 4/5. Why? Because whole number 1 and 1/5 are different fractions. So we will find their LCD. As we know that the denominator of whole number 1 is also 1. So we have 1 over 1 and minus 1/5. So our LCD is 5. And we can have 5 over 5 as the value of 1. Because 5 divided by 1 is 5 times 1 is 5. So we have 5 over 5 minus 1/5. So they are already like fractions. They have the same denominator. So we can subtract them. Again, the value of 1 is 5 over 5. If we will make it as a fraction, that the denominator is 5. 1 is equivalent to 5 over 5. So 5 over 5 minus 1/5 is equal to 4/5. So we will go to the historical gem of sigma notation. Our present way of writing sums using the uppercase Greek letter sigma is most likely due to the simple fact that it is the Greek equivalent of the English letter S, which is the first letter of the word sum. It was the Swiss mathematician Leonhard Euler who introduced this notation back in 1755. He is also responsible for many other mathematical notations we use today, such as f of x for expressing a function, f of x. Like an infinite series and sigma notation, God's love for us is infinite too. No matter who we are, He loves us unconditionally. Because of His great love for us, He died on the cross of Calvary just to save us. May we love God too with all our hearts and minds. We will serve Him faithfully with gladness until the end. So that's all for today. I hope you learned something about series and sigma notation.